Parallel lines, the notation and vocabulary. This is an introduction to parallel lines. By definition, parallel lines are lines that extend in a two-dimensional surface. That means a surface that has length and has width. They are indicated by lines with arrows on the end, and those arrows indicate that if the paper could be as big as infinity, those lines would continue on to infinity. The important thing about parallel lines is that they remain a constant distance apart from each other and that they would never intersect. So if we measure the distance between these lines at any 2 points along the line, you can see that the distance between them should remain constant. Now, of course, we're human beings and sometimes there's a little error, but the distance here is congruent to the distance here. So that's what parallel lines are. Parallel lines oftentimes are identified by a cursive L, meaning line, and then a number. Sometimes the number is large, sometimes it is subscript. So this would be line 1, and this would be line 2. Sometimes it might be a letter, and again, most often it's going to be lowercase, and often it could be cursive. So when you see things written in lowercase next to a set of lines that appear to be parallel, what the intent is to label each of those lines so that they can be referred to. It could be this way, it could be this way. And again, they use the cursive L because they don't want a printed L to look like a 1. When two lines are parallel, unless you are trying to prove that they are parallel, you will be given some information. And it will oftentimes look like this. Given, and then a colon, and it will use one of these two notations. Generally they aren't mixed, like they're not going to talk about this line and label it L sub 2 and talk about this line and label it lowercase a. They'll use this notation or they'll use this notation, but it will be written as line sub 1 is parallel to line sub 2. So when you see these little pairs of vertical lines, we read that as line 1 is parallel to line 2. And if you are given that, then even if they look a little wonky, the intent of the author or the book or the worksheet is that these two lines, for the person working with them, you assume that they are parallel. So this is geometric notation for is parallel. This is geometric notation for indicating the lines. Today you're going to be looking at parallel lines that have something called a transversal. Trans, the word part, means across. That's one of the meanings of it. A transcontinental railroad means that it is a railroad that goes across the continent. Transatlantic flight in an airplane is a flight that goes across the Atlantic Ocean. So a transversal is a line that cuts across two parallel lines, specifically in geometry. So I'm going to have a line that is not parallel to L1 and L2, or line A and line B, and it is going to cut across. And this line is referred to as a transversal. And it oftentimes will also have a label. So it will be L3 perhaps. When you see it, if you know these two lines are given as being parallel, they oftentimes will not indicate that this line is a transversal. It will be understood that if you have two parallel lines and you are told that they are parallel and another line is crossing them at 2 points, that this line that is not parallel to the other two is the transversal. Finally, angles. Angles are referred to that are created by this transversal as interior angles, and those are the angles that come between the two parallel lines. So this angle right here would be an interior angle because it lies within the boundaries of the two parallel lines. So interior makes sense. It's inside of the two parallel lines. And then these angles that are not interior angles are going to be exterior angles. So we have 1, 2, 3, 4 exterior angles, and we have 1, 2, 3, 4 interior angles. When you only have one transversal, you end up with 8 angles that are formed. 1, 2, 3, 4 exterior angles, and 1, 2, 3, 4 interior angles. These interior angles have special relationships to each other, and that is what I'm going to ask you to discover today when you work together. The final thing I want to talk about is how these angles are referred to. In the work that you're going to be doing today, the angles are going to be numbered, and the order of the number does not really matter. This can be angle 1, this can be angle 2. Then the person who created the activity could come down here. They could call this one 4, this one 5, but they also could have put 4 and 5 down here as well. So when you see a little number next to an interior angle, it is going to be referring to the angle that is created by the transversal and one of the two parallel lines. You can also name an angle by any 3 points. So if this was A and this point here was B and this point here was C, I could call this angle 2 angle CBA or angle ABC. Usually when you have parallel lines, you use numbers to talk about the interior and exterior angles because it starts getting challenging to keep track of all of the letters, because you would have to have 3 points for every single angle that there is. And it's just handier, it's just easier if you can identify them by their number that whoever created it associates with it. Now the last thing I want to talk to you about is the notation for angle. It's not a greater than sign, but it's similar to a greater than sign. It is horizontal on the bottom and it angles up from the vertex. So this means angle. If there's an M in front of it, it means the measure of the angle. So this simply means angle. This means the measure of the angle. So if you were asked to find the measure of angle 6, this notation would be used. Find the measure of angle 6. It would be written like that. And so you would know that you need to determine what this angle measure is using your protractor. If you need to extend the lines to get a good read, you can always do that when you're using your protractor to help you get a better measurement. I would not measure any more distinct than a 1/2 degree, and I would even say round to the nearest whole degree on these. We're just beginners. And so that takes us to the end of parallel lines and the notation and vocabulary used with them.